This is part 3 of section 4 in chapter 1, conditional statements and their converses. Here's a couple of examples of statements that look similar, and they're going to ask you if the statement is true or false. So for number 1, it says if x plus 1 equals 5, then x equals 4. That's a conditional statement. Is it true or false? That's a true statement. If x plus 1 equals 5, x must be 4. Notice what the hypothesis is, and notice what the conclusion is. When we go down to number 2, the word if and the word then stay where they are, and we switch the hypothesis and the conclusion. That's going to make a new statement, and it doesn't necessarily mean the same thing as the one before. If x equals 4, then x plus 1 equals 5. That's also true. So in this situation, we switched hypothesis and conclusion, and they meant the same thing. They had the same truth value. Let's try another one. If a shape has 3 sides, then it is a triangle. True statement. Keep if and then where they are. Switch the hypothesis and the conclusion. If a shape is a triangle, then it has 3 sides. It's also true. We switched hypothesis and conclusion, and it still had the same truth value. You think it's always going to be that way. These were mathematical examples, and it seemed like hypothesis and conclusion switching has the same truth value as the original conditional. What that process was called was the converse. The converse of a conditional statement is formed when you exchange the hypothesis and the conclusion. Here's a good example. Has nothing to do with math, but I think you're going to see the difference. If the Steelers win the Super Bowl, then Mr. Ryer will be happy. That's a true statement. The converse would be this. Switch the red and the blue, keep if and then where they are. If Mr. Ryer is happy, then the Steelers won the Super Bowl. Does the converse have the same meaning as the conditional? It doesn't. It uses all the same words, but it doesn't mean the same thing. The condition for the converse is that Mr. Ryer is happy. I can be happy for other reasons. It doesn't have to be only if they win the Super Bowl. I could be happy if I won the lottery, or maybe I got a new vehicle, or I just had a lucky day, perhaps. The conditional statement does not always mean the same as the converse. Sometimes it can. We saw those examples. Here's a great example of a situation where they don't mean the same thing. So that's another thing that we're going to have to do in this section. We're going to have to identify or write the converse of a conditional. Okay, so we have a new statement here. There's no color coding on it. You can pause this and try to complete these exercises. We're going to identify hypothesis and conclusion. We're going to write 2 other forms of the statement. We're going to write the converse, and then we're going to see if they mean the same thing. Go ahead, pause the video. Do this on your own. We'll be back in a second. So your conditional statement is, if a figure is a square, then it has 4 sides. That's definitely a true statement. Squares have 4 sides. The hypothesis, notice, is underlined once. A figure is a square. The conclusion is underlined twice. It has 4 sides. Let's write two other forms of this statement. So go back to that template if you need to. The conditional statement has the word if first and the word then in the middle. That's statement number 1. So we need to write statement 2 and statement 3. Statement 2 says, say the conclusion first. Say the word if in the middle. Say the hypothesis last. This is another one of those situations where you have a pronoun. The pronoun is in your conclusion. So if you say the conclusion first, it has 4 sides. If it is a square, or if the figure is a square, it doesn't make as much sense as if you said the noun first, say the pronoun second. So we're looking for this. A figure has 4 sides if it is a square. That means the same thing as the conditional. Statement number 3, we're going to take the word if and then out altogether. All squares have 4 sides. That means the same thing. If you notice, the word figure wasn't used there. If you wanted to, you could put it back in there. You could say all figures that are squares have 4 sides. Converse. Switch the red and the blue, but don't move the word if and then. So, if a figure has 4 sides, then it is a square. Notice again how we have the pronoun situation there. Use the pronoun second. If a figure has 4 sides, does it have to be a square? It doesn't. There's a lot of counterexamples to this conjecture. One of them would be a trapezoid. Trapezoids have 4 sides, but trapezoids are not squares. So the truth values of the conditional and the converse are not the same. They're different. That's really the point of this whole lesson. You're going to see mathematical statements and definitions in your text. You need to know whether or not they mean the same thing. So that's really kind of the point of this whole lesson.